Okay, long division. The longer version of this explains a lot about why you do what you do. The only thing I'll kind of notice here that's kind of handy to check, you've got 5x squared here, and when you go through the algorithm, you have a 3x squared here and a 2x squared here. Now, since these are both subtracted, as we know from the algorithm, from this ultimately, that matches up. We've got all the 5x squared here, it matches the 5x squared here. Also, we have a negative 7x cubed, well, you have a negative x cubed and a negative 6x cubed. Adds a negative x cubed here, negative 6x cubed here. Adds up to the same thing this does. You got a minus 3x, well, you've got a minus 6x here, and a plus 3x here, which adds up to minus 3x. Okay? So that's a good way to check your work. However, to do the algorithm, we divide the x into the 2x to the fourth, we get 2x cubed. We multiply that back by x minus 3, we get this expression. We subtract this expression from this, giving us this. Got to be careful to subtract. Then we divide x into x cubed, we get negative x into negative x cubed, we get negative x squared. Multiply that here and we get this. And subtract this from this. Okay? And this subtracts off, we get the 2x squared here. We divide 2x squared by x, we get 2x. Multiplying it back, we get 2x squared minus 6x. Subtracting this from this, 2x squared subtracts off. The negative 3x and minus the negative 6x gives us a plus 3x. Divide x into 3x, we get plus 3. Multiply it back, we get this. We subtract negative 9 from 5, we get 14, that's our remainder. And we write then 14 over our divisor. So that we could then say that the rational expression, 2x to the fourth minus 7x cubed plus 5x squared minus 3x plus 5 divided by x minus 3 equals 2x cubed minus x squared plus 2x plus 3 plus 14 over x minus 3. And there's much more we can say. Another thing we can say is that 3 isn't a root, 3 isn't a zero of this expression. If it was, we wouldn't have gotten a remainder, and so forth.